The term confusion matrix describes a table used in a machine learning to understand the performance of different classification models. Confusion matrix is the foundation of different model evaluation metrics such as precision, recall, and F1 score. So let's have a conceptual as well as practical understanding of different model evaluation metrics. Let's imagine this student is our machine learning model and we are going to train this machine learning model with some data. Data is nothing but bunch of books. Just like students learns from the book, machine learning model learns from data. Here we can see our model training process is going on. Once our model training process is completed, we are ready with our model. But before moving forward, we need to evaluate performance of our machine learning model to assess how our model has learned from the data. But how to evaluate our machine learning model? There are different machine learning model evaluation metrics. Performance evaluation metrics for classification based machine learning models are confusion matrix, accuracy, precision, recall, F1 score, specificity, false positive rate, true negative rate, false negative rate, and lastly AUC score. Performance evaluation metrics for regression based machine learning algorithms are mean square error, root mean square error, and R square. In this tutorial, we are going to cover the following points: confusion matrix, accuracy, precision, recall, also called as sensitivity or true positive rate, F1 score, specificity, false positive rate, true negative rate, false negative rate, and lastly, we are going to implement all these metrics in Python. By end of this video, you will be able to understand all these metrics theoretically as well as practically in Python. Now, let's move on to the first topic, that is confusion matrix. Before moving to the confusion matrix, we need to understand some basic terminologies used in a confusion matrix to understand confusion matrix in a better way. There are 4 components of confusion matrix. First component is true positive. Model predicted it's a positive class example and it's a true statement because actually it is a positive class example. That's why it is called as a true positive. Second component is false positive. Model predicted it's a positive class example and it's a false statement because actually it is a negative class example. That's why it is called as a false positive. Third component is false negative. Model predicted it's a negative class example and it's a false statement because it's actually a positive class example. And the last component is true negative. Model predicted it's a negative class example and it's a true statement because actually it is a negative class example. Confusion matrix consists of 2 parts: actual class labels and model predicted class labels. Consider an example of email classification, in which actual positive class is spam class and actual negative class is not spam class. Similarly, model predicted positive class is spam and model predicted negative class is not spam. The first component of confusion matrix is true positive. What is true positive in this case? It is total number of spam examples classified as a spam by our model. The second component is true negative. It is also total number of non-spam examples classified as a not spam by our model. The third component is false positive. It is the total number of not spam examples classified as a spam by our model. It is also called as a type 1 error. Consider a null hypothesis could be the email is a not spam. And in type 1 error, we are going to reject the null hypothesis even it is true. So we reject the null hypothesis means we accept the alternative hypothesis. The alternative hypothesis in our case is this email is a spam email. The last component is false negative. False negative is nothing but total number of spam examples classified as a not spam. It is also called as type 2 error. Type 2 error is nothing but we are going to fail to reject null hypothesis. So we accept the null hypothesis even it is false. So what is the null hypothesis in our case? Our email is a not spam. So this is all about confusion matrix. I am going to explain type 1 error and type 2 error in another video. So we will have in-depth knowledge of type 1 error and type 2 error in that specific video. Now let's move on to the another evaluation matrix, that is precision. Precision is an evaluation metric used in a machine learning, particularly in a classification tasks. It measures the accuracy of positive predictions made by a model. In simple words, precision answers the question when the model predicts something as a positive, how often it is correct. To understand precision, let's consider an example of email spam detection. Consider this is an confusion matrix for the problem of email spam detection. It is having 4 components, that is true positive, second is true negative, third is false positive, and lastly false negative. The formula for precision is true positive, that is total number of spam examples classified as a spam by our model, divided by true positive plus false positive. False positive is nothing but total number of not spam examples classified as a spam. Precision is the proportion of cases that are correctly identified as a true positive by the model. Precision measures the ability of model to avoid false positives. If the model having high precision, then the model has low false positives and is good at identifying positive instances correctly. On the other hand, a low precision value indicates a high rate of false positives, meaning that model incorrectly identifies non-spam emails as a spam more frequently. Precision is important when we are specifically interested in true positives predicted by our model. It focuses on the accuracy of positive predictions and helps us to evaluate how well the model performs in correctly identifying positive instances. If the priority of your problem statement is to predict true positives correctly, then you need to have a model with good precision. Now let's move on to the another evaluation matrix, that is recall, also called as a sensitivity or true positive rate. Recall is an important evaluation matrix in machine learning, particularly in a classification task. It measures the ability of model to correctly identify all positive instances out of total actual positive instances. In simple words, recall answers the question when the actual value is positive, how often does the model predict it is positive? To understand recall, let's continue with the same example of email spam detection. This is the confusion matrix for the email spam detection problem. The formula for recall is true positive, that is total number of spam examples classified as a spam by our model, divided by true positive, that is total number of spam examples classified as a spam, plus false negative, that is total number of spam examples classified as a not spam. Recall is the proportion of actual positive cases, that is actual positive examples in the dataset which are correctly identified as a positive by the model. Recall measures the ability of the model to avoid false negatives. If the model having high recall, then the model has low number of false negatives. On the other hand, a low recall value suggests a high rate of false negatives, implying that the model going to miss a significant number of positive instances. If you cannot afford to miss true positive cases, then you need to have model with good recall. This is all about precision and recall. Let's understand trade-off between precision and recall. The first trade-off that we will have is high precision and high recall. Consider we have a model with high precision and recall, then we can say that our model is good at prediction of positive class. This is the ideal or desired outcome for any machine learning or deep learning model, because with high precision we'll have low number of false positives and with high recall we'll have low number of false negatives. So this is the ideal outcome for any machine learning model. Let's move on to the another trade-off, that is low precision and low recall. With low precision and recall, our model is bad at prediction of positive class. This is one of the worst outcome for any machine learning or deep learning model, because with low precision we'll have high number of false positives and with low recall we'll have high number of false negatives. So it is not good to proceed with a machine learning model which having low precision and low recall. Now let's move on to the another trade-off, that is high precision and low recall. With high precision, our model having low or very few false positives, and with low recall, our model having high number of false negatives. This is an acceptable scenario where our model prioritizes towards reducing false positives. Now let's move on to the another trade-off, which is low precision and high recall. With low precision, our model having high number of false positives, and with high recall, our model having low or very few false negatives. This is an acceptable scenario where our model prioritizes towards reducing false negatives. So these are the different trade-offs between precision and recall. By understanding this trade-off, we can determine the appropriate balance between precision and recall to optimize our model performance for different applications. The trade-off between precision and recall allow us to make informed decision and draw conclusion based on the specific situations. F1 score is the another evaluation metric in case of classification based machine learning algorithm. F1 score is the harmonic mean of precision and recall. So before going for F1 score, you need to calculate precision and recall. We use harmonic mean of precision and recall for calculating F1 score because harmonic mean balances influence of both precision and recall, as it gives equal importance to both precision and recall. Then what is the formula for F1 score? F1 score equals to 2 multiplied by precision into recall divided by precision plus recall. From the formula, you can able to understand F1 score is nothing but harmonic mean of precision and recall. Higher F1 score indicates better performance of the model. A score 1 means model has perfect precision and recall, while score 0 means model has no precision or recall. Shortly, we can say that if F1 score near to 1, then we can say our model performing very well. But if F1 score is close to 0, then we can say our model performing worst. So F1 score is an advisable evaluation metric in case of classification based machine learning algorithm. Accuracy is another evaluation metric in case of classification based machine learning algorithm. It will provide you the overall correctness of your machine learning model. Let's continue with the same example of email spam detection. This is the confusion matrix that we obtain from test data of email spam detection. What is the formula for accuracy? It is true positive plus true negative divided by true positive plus false negative plus false positive plus true negative. With the help of this formula, you can able to understand accuracy is the ratio of addition of true predictions to the addition of overall predictions made by our model. Or we can also say that it is addition of all diagonal elements to the all elements of our confusion matrix. So accuracy will provide you the proportion of correct prediction made by your model. As accuracy is a straightforward metric, it can be misleading when dealing with imbalanced dataset. An imbalanced dataset is one where the distribution of instances across different classes is highly skewed, with one class having much larger number of instances than the other. In such cases, model may achieve high accuracy by simply predicting majority class most of the times. without effectively capturing minority class elements. So, accuracy, it is not an advisable evaluation metric in case of imbalanced dataset, because accuracy will elaborate only the majority class, not the minority class, or it will not provide you the true performance of your machine learning model. So, before going for accuracy, you need to balance your dataset. I have explained each and everything about how to handle data imbalance using different techniques. I will share link of those videos in the video description. Specificity is another evaluation metric which will provide you the information about ability of your machine learning model to identify true negative samples correctly. Or we can say that specificity represents the proportion of actual negatives that are correctly classified as negatives by our model. Let's continue with the same example of email spam detection. This is the confusion matrix that we obtain from the test data of email spam detection. What is the formula for specificity? It is true negative, that is total number of not spam examples classified as not spam by our model divided by true negative plus false positive. False positive is nothing but total number of not spam examples classified as a spam. Specificity is a metric that measures the ability of a classification model to correctly identify negative samples. A high specificity indicates that the model is good at correctly identifying negative samples, while low specificity indicates that model is bad at identifying negative class examples or samples and also making more false positive predictions. From the formula, you can able to understand if specificity is quite high or near to 1, then numerator, that is true negative value, is quite high in number. But in case if specificity is low in number or near to 0, in that case we can say that there is high number of false positives. This is all about specificity. As all of you know, this is the confusion matrix that we obtain from the test data of email spam detection. Now let's move on to the different rate matrix. This rate matrix is a kind of evaluation matrix for your machine learning algorithm or machine learning model. Let's move on to the first rate matrix, that is true positive rate, also called as recall. This matrix, that is recall, I already explained to you. It is the ratio of true positive to the true positive plus false negative. Now let's move on to the second rate matrix, that is false negative rate. It is the ratio of false negative to the true positive plus false negative. From these two formulas, you can able to understand if you have high number of false negatives in our model, then there would be high false negative rate. But again, if we have high number of true positives in our model, then there would be high recall or high true positive rate. Let's move on to the another rate matrix, that is true negative rate. It is the ratio of true negative to the true negative plus false positive. It is also called as specificity that I have already explained to you. The last rate matrix is a false positive rate. It is the ratio of false positive to the true negative plus false positive. From this rate matrix, you can able to understand if you have high false negatives, then there would be high false negative rate, and if you have high false positives, then there would be high false positive rate. False negative rate, if there is high false negative rate and high false positive rate, then we can say that our model not performing well. But in case we have high true positive rate and true negative rate, in that case we can say that our model performing well. So this is all about different rate metrics. I am going to explain these all metrics that I have explained in this tutorial practically in Python. So let's move on to the practical implementation of each and every matrix or evaluation matrix. Let's explore all the model evaluation matrix that we have seen in the earlier theoretical session of this video. For generating different kind of model evaluation matrix, we firstly need to create a confusion matrix. Let's create a dummy confusion matrix with the help of these lines of code. Here firstly we import all the necessary libraries for creating confusion matrix. Assume y underscore true is the actual labels from our data set and y underscore preds is the model based predictions for the corresponding data points or data sample. Class labels are spam and not spam. Consider 0 as a spam and 1 as a non-spam. We'll create a confusion matrix with the help of this confusion matrix module. It is a part of sklearn library. Here you can see I have imported confusion underscore matrix from sklearn library. Now I am going to transpose that particular confusion matrix because I want model predicted labels on the y-axis and actual labels or true labels on the x-axis. We'll create a heat map with the help of SNS library. SNS is nothing but seaborn. Here you can see I have imported seaborn as SNS. Inside this heat map function, we have to pass transpose matrix as a first argument. And not equals to 2 represents as displaying all the elements of that particular confusion matrix. CMap is color map of that particular heat map. X-tick labels and Y-tick labels are nothing but the class labels of that confusion matrix. And here we labelize x-axis as a true class labels and y-axis as a model predicted class labels, and also provide title as a confusion matrix. So let's run this cell for creating confusion matrix. Okay, this is our confusion matrix. You can see the predicted class labels on the y-axis and true labels on the x-axis. We are going to generate different kind of model evaluation matrix with the help of this confusion matrix. So let's see what are this model evaluation matrix. First is precision. Second is recall. Recall is also called as true positive rate. Third is F1 score. Fourth is accuracy. Fifth is true negative rate, which is also called as specificity. And again false positive rate and false negative rate. So these are the different evaluation matrix that we are going to see. Before moving to these different kind of model evaluation matrix, we firstly identify different components of confusion matrix. As we have seen, confusion matrix has 4 main components, which is first is true positive, which equals to, it is total number of samples belongs to the positive class and also classified correctly as a positive by our model. So you can see we have total 7 samples belongs to the spam class, which is a positive class, out of which 5 are getting correctly classified. Okay, so we have true positive 5. False positive is total number of samples belonging to the negative class, but our model classified it as a positive class. Here you can see total 9 samples belonging to the negative class, that is non-spam, out of which one class label or one data point is classified as a spam. So false positive is 1. Let's move on to the false negative. False negative is the number of data samples belongs to the positive class, but our model classified it as a negative class. Here you can see out of total 7 samples, 2 are getting misclassified. Here you can see. So out of total 7 samples, 2 samples are getting identified as a non-spam. So false negative is 2. Lastly, true negative equals to total number of negative samples are getting correctly identified. Our model is 8. Here you can see true negative is the nothing but samples which are belong to the negative class and also classified as a negative by our model. So total number of samples is 8, which belongs to the negative class and also classified as a negative by our model. So true negative is nothing but 8. So let's calculate or generate different kind of model evaluation matrix. First is precision. Precision having formula. Precision equals to true positive. It is proportion of true positive samples which are getting correctly identify our model. True positive plus false positive. So let's print it. Print precision dot format. Let's format this string with this value, precision value. So we have precision about 83%, which is 0.83. Let's move on to the second evaluation matrix, that is recall. Recall having formula, recall equals to true positive divided by true positive plus false negative. It is nothing but the proportion of the positive class samples or positive class examples which are getting correctly identified by our model. So we can say it as a correctly identified sample proportion of the positive class examples. So let's print this recall. Recall equals to, let's print it first. Recall equals to, let's format this recall value. Recall. So we have recall about 71%, which is 0.71. Now let's move on to the another evaluation matrix. It is also called as true positive. So let's print it here, true positive rate. Okay. Let's move on to the F1 score. F1 score having formula 2 multiply by precision multiply by recall divide by precision plus recall. So let's print this F1 score. Okay, F1 upon score. Let's format this value, F1 underscore score. So F1 score is about 0.76, which is quite good. Now second evaluation matrix after F1 score is accuracy. Accuracy equals to all the addition of all the diagonal elements, that is true positive plus true negative divided by all the elements belongs to the confusion matrix, that is true positive plus true negative plus false positive plus false negative. So this is the accuracy. So let's print accuracy. Accuracy equals to, let's format this value with this accuracy. So we have accuracy about 81%. So what is remaining? Specificity. Specificity is nothing but, let's copy it from here. Specificity equals to, it is actually total number of negative samples which are getting correctly identified, or proportion of total number of samples, or proportion of samples actually belongs to the negative class and correctly identified by our model as a negative. So it is having formula true negative divided by true negative plus false positive. So let's print this. You have to remember all these formulas for calculating these different evaluation metrics. Specificity, let's format this value with the help of specificity. So we have having true negative rate or specificity about 88%, which is 0.88. So let's move on to the another evaluation matrix, that is false positive rate. False positive rate equals to, it's having formula false positive divided by false positive plus true negative. You have to remember all these formulas to evaluating all these confusion matrix. So false positive rate is, let's format this value again. Okay, it's wrong, totally wrong. It's false positive rate. Okay, false positive rate is about 0.11. And lastly, false negative rate. False negative rate, it is having formula false negative divided by true positive plus false negative. Let's print this false negative rate. False negative rate equals to, okay, false negative rate. We have about 28% false negative rate. So we have done with our all the evaluation metrics. So if you want to verify the precision recall and F1 score, you can use classification report module from the sklearn library. So let's use it. So firstly, we need to import classification report from sklearn. From sklearn, okay, there is a typo mistake. Sklearn dot metrics. We import classification underscore report module. With the help of this classification report module, we'll verify our precision recall and F1 score. Inside that, you have to pass your true predictions, that is true labels, and your model based predictions. Okay, let's print it so you'll able to see it properly. Oh, okay. So here let's compare. 0 is nothing but our spam class. So let's compare our precision is correct or not. Here you can see precision is about 0.83 and 0th class, which is spam class, having precision 0.83, which is correct. Also recall is 0.71. So our recall value is also correct. F1 score is 0.77. It is also correct because once we round figure it, it is 0.77. So we have done with all the evaluation metrics in case of by considering spam class as a positive class. Now let's move on to the negative class, that is non-spam class. For that, we have to consider non-spam as a positive class and spam as a negative, because we are going to find or we are going to identify all the components of confusion matrix by considering non-spam as a positive class. I'm not going to type this again. I just copy it because we just modify this. In case of by considering non-spam as a positive class, we are going to find out, or we are going to generate different kind of evaluation metrics. But before that, we firstly need to identify all the components of confusion matrix. So in case of non-spam as a positive class. So true positive is total number of samples belonging to the positive class, that is non-spam, and also classified as a positive, which is non-spam by our model. So total number of samples are 8. Here you can see, which are getting correctly identified as a not spam. So in case of true non-spam as a positive class, true positive is 8. False positive is nothing but originally it is belong to the negative class. In case spam as a negative class, and our model predicted it is not spam twice. So we can say that the false positive is 2. False positive is 2. False negative is nothing but originally our data samples or number of samples belonging to the positive class, but our model predict it as a negative class. So we can see here total number of samples belonging to the positive class, which is non-spam, but our model predicted it as a spam. So it is a true negative. So true negative value is 1. Sorry, false negative value is 1, and true negative is nothing but negative samples are also classified as a negative, which is 5. Because in case of by considering non-spam as a positive class, now let's generate all the evaluation metrics in case of non-spam class. For that, I just copy these all formulas because I am not going to write it again. In case of non-spam class, we have different true positive, false negative values, false negative, false positive, and true negative values. So just in case of non-spam class, true positive is total number of samples belongs to the non-spam and also classified as a non-spam correctly by our model, which is 8 here. You can see total number of samples belongs to the non-spam class. True labels are 8 here and also classified it as a non-spam. So here you can see total out of total 9 samples, 8 are getting correctly identified as a non-spam. So true positive is 8. False positive is total number of samples belong to the negative class, but our model predict it as a positive class. So total 2 samples belonging to the spam class, but our model predict it as a non-spam. So false positive is 2. False negative is total number of samples belongs to the positive class, but our model predict it as a negative class. So one data point belonging to the non-spam class, but our model predict it as a spam. So let's write it here. False negative is 1. True negative is total number of samples belonging to the spam class and also classified it as a spam, which is 5 here. True negative is 5. So let's run this cell. No, this is the wrong cell actually. True negative is 5. So let's run this cell. So we'll have all these evaluation metrics. Let's compare these evaluation metrics in case of non-spam class with the classification report. So in case of non-spam class, that is this one class label, precision is 0.8, which is correct. Here you can see precision is 0.80. Recall is about 0.88, which is also correct. Here you can see recall is about 0.89. Once we round figure this value, we'll have 0.89. F1 score is about 0.84, which is also correct. And accuracy is 0.81, which is also correct. So we are done with our all evaluation metrics in case of spam and non-spam class. I will share a link of this Jupyter notebook in the video description, so you will be able to access it properly. This is all about different evaluation metrics that we specifically use for evaluating our machine learning model. Here you can see in case of both spam and non-spam class, we have good precision, recall and F1 score as well as accuracy. So these are the good results. So you can use this different evaluation metrics to evaluate your machine learning model or deep learning model. So this is all about different model evaluation metrics that we specifically use to evaluate our classification models. Thanks for watching. If you enjoyed the video, please subscribe my YouTube channel and see you in the next exciting video.